So trigonometric graphs are of three types: sine, cos and tan. First we'll look at the sine graph, so y equals sine x. To make sketching easier, we can use the table function of the calculator. So we'll input sine x 0 till 2 pi. So this is giving at 0, sine is 0, sine y is 0. At, so I'll label the axis first. This is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. When this is, let's say this is 1, and then this is minus 1. So first at 0 we have 0. This is pi by 2. At pi by 2 we have 1. Then at pi we have 0 again. At 3 pi by 2 we have negative 1. So we're here, and then at 2 pi we have 0 again. Right? So this is just a rough sketch. So this is the standard shape of a sine graph, and for this graph right now the domain is from 0 till 2 pi. If we extend the domain till, let's say, negative 2 pi, we'll have a reflection of this in the y-axis. Sorry, not a reflection of it. It will move like this, right? We'll have at negative pi by 2 we'll have negative 1. Then at negative pi it will be 0. Then at negative 3 pi by 2 we'll have 1. And then 0 at negative 2 pi. So the graph is like this. Now the domain is negative 2 pi till 2 pi. This is the basic sine graph. Now next will be the cos x graph. So now I'll input cos x, right? So we're getting at 0 degrees, we're getting 1 as the image. At pi by 2 we're getting 0. At pi we're getting negative 1. And at 3 pi by 2 we're again getting 0, and then at 2 pi we're getting 1. Sorry, 1. So the graph is somewhat like this. If we this was for the domain from 0 till 2 pi. If we extend this and our domain is from negative 2 pi to 2 pi, it will be a reflection in the y-axis. We'll have 0 over here, negative 1 here, 0, and then 1. So it will go like this. Right, so this is the basic shape of the cos x graph. Next is the tan graph. Now the tan graph is a little complicated as compared to the sine and cos graph, so I'm inputting tan x into the table function. Now I'll take this step as 0 and end the start as 0 and end as again 2 pi, but I'm taking the step as pi upon 4. Earlier I was taking pi upon 2, now I'm taking pi upon 4. So now each x value is differing by pi by 4 over here now. So at 0 radians we have 0 as the image. At pi upon 4, okay, I forgot to label it. So pi by 2, pi, 3 pi by 2, and then 2 pi, half 1. Okay, so at 0 we have 0 radians, we have 0 as the image. At pi by 4 radians we have 1 as the image. Pi by 4 will be in the middle, and then 1 at pi by 4. Then at pi by 2 we can see an error over here. This shows that at pi by 2 there will be a vertical asymptote and the curve will not touch that line, so which is why it's giving an error. So I'll draw an asymptote here. So this means that the graph is increasing till pi by 2, and at pi by 2 it's reaching infinity, right? I'll show that in more detail in just a few seconds. So I'll plot the other points first. Then at 3 pi by 4 it's negative 1, right? 3 pi by 4 will be over here, this is negative 1, and then at pi it's 0. Then at 5 pi by 4 it's again 1, so somewhere here, and then at 3 pi by 2 it's again an error, that means it's again undefined, there is an asymptote here. After that there is 3 pi by 2 plus pi by 4, that's giving negative 1 over here, and then at 2 pi it's 0, right? So now to show the asymptote, what I'll do is I'll take tan pi by 4, that's giving me 1. Then let's add 1 to this, we're getting, sorry, not 1, we can't take a value above pi by 2, so we'll add pi by 10, let's say. So we're getting 1.96, right? Pi by 10, it's after pi by 4, we're getting 1.96. Just like that, if we have pi by 6, we'll get 3.73. So if you keep on going, it will keep increasing, but it won't, but when you reach pi by 2, there's an error, because at pi by 2, it's reaching infinity. So we draw the graph like this, right? Similarly from here, there's a negative infinity over here, so the graph will come from below and it will go towards positive infinity. Right? So I can also show this in terms of angles. If I take this in degrees, so this is 90, so this is tan 45. At tan 45 we have 1, then at tan 50 it's 1.19, at tan 70 it's 2.74, at tan 80 it's 5.67, at tan 89 it's 57 point something, and then tan 89.999. the value is increasing, but the moment you touch tan 90, it's a math error, right? I hope this is clear. Okay, so one more thing, over here in these examples I took the x-axis or the domain in radians, right? But I'm not going into detail right now because this has to be a short video. So these could have been, this can also be in degrees, that depends on the domain given in the question. I just took radians for now, but you can easily convert these to degrees. This would be 90, this would be 180, then 270 and 360. Similarly for all the other graphs, you can convert the radians into degrees and it won't have any difference on the shape of the graph, right? So these were the basic shapes. Now the second thing is, there's a term called the period of a graph, right? Period is the time interval or the interval in which the whole graph is completed, right? One whole cycle of the graph is completed. That means that from here till here you can see that this is one cycle, right? After that the cycle will be repeated. So in a sine graph, the cycle is of 2 pi radians or 360 degrees, right? So one cycle is 2 pi radians or 360 degrees. After that it will repeat itself again. Similarly in the cos graph, again the cycle or period is from 0 till 2 pi, that is 2 pi radians or 360 degrees. So in cos graph, again period or cycle is of 360 degrees or 2 pi radians, after which it will repeat itself again, as you can see over here. But in the tan graph, you can see that the period or the cycle is from 0 till pi or from 0 till 180 degrees, that is of 180 degrees or pi radians, because after that you can see that again the same thing is being repeated, right? So over here the period or cycle is of pi radians or 180 degrees. Now after the basic shape, we have some transformations in these trigonometric graphs. So the transformations that we have in syllabus are translation, There's translation, there's stretch, and there's enlargement. So I have a video on transformations of functions. You can see that to clear this concept. Now, for example, this was the basic sine graph. I'll be working only from 0 till 2 pi radians right now. I'll be ignoring this part. So let's say we have to draw the graph of y equals sine x plus 1, right? So over here there is a translation of 1 unit upwards. So every unit will be shifted upwards. This is 0, this will go to 1. This is pi, this is 1, this will go to 2. This is 0, it will go to 1. Negative 1 will go to 1, will go to 0, sorry, and 0 will go to 1. So after the translation, we'll get a graph like this. This is y equals sine x plus 1. Now let's draw the graph of y equals 2 sine x. So this 2 represents a vertical stretch of 2 units of stretch factor 2. So what happens is that from the x-axis every point's distance is multiplied by the stretch factor. So every point's distance from the x-axis will be multiplied by 2. This point has a distance of 0 from the x-axis, so this will remain over here. This is 1, so 1 times 2 will be 2. This is 0, it will remain here. This is negative 1. Negative 1 times 2 will be negative 2. This is 0, it will remain there, right? So sketch the graph for this. It will be like the graph has been stretched, right? So this is for y equals 2 sine x. Okay, I made a mistake over here. There's not enlargement in the syllabus. There's reflection. Right. So what else can we have? In reflection, we can have y equals negative sine x. This will be a vertical reflection, right? So what happens is that every point will be multiplied with negative 1. 0 times negative 1 remains 0. 1 times negative 1 goes to negative 1. 0 times negative 1 remains 0. Negative 1 times negative 1 goes to 1. And 0 remains there. So this is the dotted graph, is the graph for y equals negative sine x. These were the vertical transformations. Now for horizontal transformations. Yeah, so for horizontal transformations, I'll make a new page. Now in horizontal transformations, there can be reflection in the y-axis, right? So for that we'll have y equals sine negative x, right? This means negative over here represents a reflection in the y-axis. So we'll reflect the graph in the y-axis, right? So the graph would be like this. This will be y equals sine negative x. Then there's translation. Now in horizontal translation, if there is a plus sign, that means that the translation is towards the left, and if there is a negative sign, that means the translation is towards the right. So if I perform the translation sine x minus x plus pi by 2, this means that we're translating sliding the graph by pi by 2 radians towards the left because there is a plus, right? So it's going towards the left. Every point will go by pi by 2 units towards the left. So this will be translated here. This point will go here, this point will go here, this point will go here, and then this. So this will be y equals sine x plus pi by 2. Then lastly there is the horizontal stretch. Now in horizontal stretch the concept of cycles will come, right? So if I have y equals sine 2x, now in horizontal stretch the digit being this stretch factor is basically the reciprocal of this digit. So the stretch factor over here will be half, right? So that means that the graph is being shrinked. So if this graph, the blue one, is being shrinked, that means that its cycle will become half, because this point will come here. I'll draw it first. So every point's distance on the y-axis will be halved because that's the stretch factor. So this point will move here, this point will move here, this point will move here, and then this point will move here. So we'll have this graph. Earlier the cycle was 2 pi radians, but now we can say that a cycle is pi radians. So horizontal stretch alters the cycles. So if we have 2x, that means that the cycle will become half. If we have 3x, the cycle will become 1/3. Similarly, if we had y equals sine 1 over 3x, now what will happen is that the stretch factor will be 3. So the distance of every point from the y-axis will be multiplied by 3. I'll draw a new graph for this. So now this is the normal sine graph. We have to make y equals, we have to sketch y equals sine 1 over 3x. This means that the stretch factor is equals to 3. So this means that the distance of each point from the y-axis will be multiplied by 3, right? So 0 times 3 will be 0. Now the distance of this is pi by 2. So pi by 2 times 3 will give 3 pi by 2. So this will move here. Now this is pi, the distance of this point is pi. Pi multiplied by 3 will be 3 pi. This is 3 pi by 2. 3 pi by 2 multiplied by 3 is 9 pi by 2. 9 pi by 2 is 4.5 pi, right? So it will be over here somewhere between 4 and 5 pi. And then after that there is 2 pi. 2 times 3 is 6, so 6 pi. So the graph is like this. Right, so it has been stretched horizontally. And now in this case, earlier initially in the normal sine graph, the period or the cycle is 2 pi radians or 33 degrees. Now when we sketch y equals sine 1 over 3x, that gives us a period or a cycle of 6 pi radians, which is equal to 1080 degrees. So mostly the transformations that come are vertical transformations. Horizontal transformations are rarely asked in sketching. So, and especially horizontal stretch is rarely asked. So I'll be applying the transformations that we did separately in the sine graph now in the cos graph, and we'll apply them there. I've written them combined over here, so we'll apply them one by one, and then we'll form y equals -2 cos x minus 1 ka graph. So what's happening over here is that there is a reflection, a vertical reflection. There is a vertical stretch of stretch factor 2, and then there is a translation of 1 unit downwards. So first I'll perform that. I'm working from 0 till 2 pi only. I'm ignoring this part. So first I'll apply the reflection. 1 will go to -1, 0 stays at 0, -1 will go to 1, 0 stays at 0, and then 1 will go to -1. So that will give the reflection, which is somewhat like this. Right. After that I'll apply the stretch, because in vertical transformation we first apply stretch or reflection and then we apply the translation. So stretch means that, vertical stretch means that every point's distance from the x-axis will be multiplied with the stretch factor. The stretch factor is 2. So -1 times 2 will give -2. this will go to negative 2. 0 times 2 will give 0. 1 times 2 will give 2. 0 times 2 will give 0, and then negative 1 times 2 will give negative 2. Right, this is y equals negative 2 cos x. Now we have to apply negative 1, which is a translation of 1 unit downwards. So every point moves 1 unit downwards. Negative 2 will go to negative 3. 0 will go to negative 1. 2 will go to 1. 0 will go to negative 1. And then negative 2 will go to negative 3. Right, so it's somewhat like this. This is the graph for y equals negative 2 cos x minus 1. That was more or less it about sketching. So whatever the graph they ask, you can apply the transformation and easily sketch it. Now sometimes we're given equations of such form and we're given the graph with it and asked to find the values of a, b and c. So how will you approach these questions? So over here you can see that this is the graph after the transformation, right? Before the transformation, there's a translation of c units over here. Before the translation, the graph would have started at the origin, because this is the sine graph, so it would have started at the origin. Because of the translation, it reached 3, the vertical translation. So that's why c should be equals to 3. Then there's a and b. So b represents the number of cycles, right? If b is over here, we can see that one cycle is ending at pi, right? Because this is one complete cycle. So if one cycle is ending at pi, that means that the stretch factor was half. So if the stretch factor was half, then b should be equal to 2. One more way of seeing this is that in all cases, b basically shows how many cycles you'll get in the standard cycle. The standard cycle was 2 pi. Now we're getting 2 cycles in the standard cycle. So that means that b will be 2. That's another way of approaching it. Then for a what we do is that take the maximum point and the initial point, right? And find their difference. So 9 minus 3 will give us 6. So a will be equals to 6. And why is this? Because initially, before the translation, the graph would have been somewhat like this, before the vertical translation, right? So this point would have been 6, because 9 minus 3 is 6. So this here you can easily see that normally the graph of sine is maximum at 1. Now because of a stretch factor 6, it reached the point 6. Then it was translated upwards. So that's why a will be 6. In this question, there's again a sine graph, and they're asking for the values of a and b. Now over here, a is representing the vertical translation. So a will be 1, because the initial point has moved to 1. And for b, we'll take the maximum point and the initial point's difference. So 3 minus 1 will give 2 as b. In this question, again, there's a sine graph and they're asking for a and b. So over here, you can see that the a again represents the vertical translation, and the initial point has moved 2 units downwards, right? So a will be negative 2. And for b, we'll take the maximum point and initial point get difference. That is 1 minus minus 2, that is 3. Another way of doing this could be to take coordinates. This point we know is 0, negative 2, right? And this point, the maximum point is at pi by 2, right? So this will be pi by 2, 1. Now using this equation, I'll first substitute these points into the equation. So minus 2 equals a plus b sine 0. Sine 0 is 0, so that means that a is negative 2. Now I've gotten a, so the equation is y equals minus 2 plus b sine x. I'll use this point now. So 1 equals negative 2 plus b sine pi by 2. Sine pi by 2 is 1. 2 moved there will become 3. 3 equals b. Same answer, right? Then this question, diagram shows part of the graph of y equals, again there's a sine graph, but now over here there is a horizontal translation. Find the value of alpha and the value of k, right? So firstly, over here, the point on the sine graph where it intersects the x-axis for the second time is normally 180, means it should have intersected over here, but this point has moved 30 degrees towards the left. That means that alpha was 30 degrees, which is why it moved, which is why a horizontal translation of 30 degrees was applied and it moved to 150, right? So now we have the equation as y equals k sine theta plus 30 degrees. Now this point is 0, 2. We'll substitute this point over here to find k. So we'll have 2 in place of y. K sine 0 plus 30 will be 30. So 2 upon sine 30, 4. K is equals to 4. Now in this question, there is a tan graph and we have to find the values of a and b. The diagram shows part of the graph of y equals a plus tan bx, where x is measured in radians and a and b are constant. The curve intersects the axis. We have 2 points given. Find the value of a and b. So this can easily be done using the points as well. So substitute the points. For the first one, 0 equals a plus tan negative b pi upon 6. Okay, and for the second one, root 3 equals a plus tan 0b, right? So this will be 0. Tan 0 is 0. So that means that a equals root 3. So we have 0 equals root 3 plus tan negative b pi upon 6. Now, I'm erasing this. We can have negative root 3 equals tan negative b pi upon 6. This will give negative b pi upon 6 equals tan inverse negative root 3. Tan inverse negative root 3 is negative 60, right? Sorry, this is in radians, so I'll convert it to radians. So negative pi by 3. Equals negative pi by 3, right? So negative cancelled, pi cancelled, 3 1s are, 3 2s are, so b equals 2.